I'm gonna
Whoa, you little piggy.
Is it gonna start? Oh, you're gonna start spinning.
Yeah, it's just gonna start spinning on its own.
Really fast. Whee! I'm getting dizzy.
I can't do it. It makes me.
She's gonna throw up.
After I did it.
Go again.
Bet you can't.
I get dizzy just passing out papers if I'm like turning around trying to find something.
I know. I can't watch her. Okay.
That's you.
Watching NASCAR makes me sick.
All right, now I want you to stay sitting there. You're going to do something else.
Uh-oh.
Hey, can she put this on her head and spin and see what happens?
Oh, to see what that does? Okay.
Can we spin with that? Like,
I have simple pleasures. I really like it.
what is that? Is that brownie? No.
I'm gonna laugh.
All right. Now, this has rotational inertia. This is a radius. This has some mass. Right? And so it takes something to start it going, and it takes something to stop it. And if it is on your head and it doesn't get wound up in your hair or something, that is your head doesn't connect with that very well. So this pretty much stays put, and you spin under it. Okay. Now the reason that it balances like this, and the reason that a hanger stays on the pole, and the reason those little birds that you can see that you can balance, or the golfer that you can balance, or the ballerina you can balance on it, the reason those work is that the center of gravity, which is you take all of the mass and you pick the center of where that mass is like right here. And if the center of gravity is underneath the suspension point, then it will balance like this.
So you just take a regular old hanger.
Regular old hanger. And you bend that and make it, this is the, see this part right here is the part that, goes up to the hook.
that little twisty part?
Yeah.
Okay,
And this is just right in the middle. See, these are the
I'm going to see if I can get some
end
tennis
parts,
balls
yeah.
and hangers
Yeah,
and
you
we'll
can
make
make
that one day. Wouldn't that be awesome?
That'd be so much fun.
That'd be fun.
That'd be super
I
fun.
could walk around the school all day.
Okay, now the next thing we want to look at is I have here a wheel.
Oh, okay.
And if I grab hold of this wheel by this rope,
It's
it
a tire
hangs like
swing.
this. If, however, I take this wheel and spin it, it stays up. And it precesses. Now, the mathematics for this is beyond this level of physics. In rotary motion, when something is spinning around, it's spinning around in radians per second. Normally when something's moving, the vector that describes that motion is the same way it's going. So if a car is going 60 miles an hour that way, that's the way the vector is. But when this is spinning, the vector comes out along this. It is in the plane of rotation. It's perpendicular to the plane of rotation, following something called the right-hand rule. If this thing spins to the right, the velocity vector is this way, and the opposite, it spins the other way. So what happens is you have this vector out here, and you have gravity trying to pull it down, and that gives you this precession that you see of it spinning around. So I want you to put your feet back up on there, and I want you to grab hold of both of these. Hold it straight out in front of you. All right, now I want you to twist it back and forth.
Like that?
Like this. All right? Okay, see how that feels? That's pretty easy to do, okay? Now what I'm going to do is I'm going to start spinning that.
Hold on, arms get tired.
Okay, I'll let you do this.
How heavy is it?
Okay.
You
Now,
fatty?
what I want you to do is I want you to take it like this, and I want you to turn it like that.
Okay.
And then after a while, bring it back, and then turn it like that. Okay?
Hold on a second.
Okay, I'll let you.
Okay. You start working out.
I was going to say, I hope you weren't the
Right.
Whoa, Mr.
The
Hankie.
bottom on the stump.
Turn it back the other way.
Our arms are getting tired.
All right, do you see what's happening to her? Do you see what's happening to her?
Yeah. A little bit straight version.
Okay, now when it was spinning, was there more force on that than when it was just still? Could you tell the difference?
Yeah, it was heavier.
It was harder to turn. Right?
Yeah.
Okay. Somebody else want to try?
Brett, you want to do it?
Yeah.